So there's this guy, Boy What. He uses AI specifically with SpongeBob characters to create songs based on SpongeBob, I guess, storylines. So if you look up like a Neon Tide, there's a 2023 song, and it's basically Plankton just like rocking out. It shouldn't be as good as it is, but yeah.
Nice.
Yeah.
I was pretty amazed with this one. Here's the lyrics, here's the style, here's the title, click go, and seconds later it starts streaming a song for you.
Yeah, I messed around with
swing to it or something like that.
Yeah, or I think I have a couple sitting in like my library there where it was like IT related songs in like a Jangle Rock Gin Blossoms style. So
I'm typing in right now. Let's create some great IT and OT operational technology songs. Suggest 10 song titles.
This is gonna be
okay.
Great.
Here we go. Yep. Here we go. Number 1 is The Ballad of the Firewall and the Factory Floor.
Wow.
Number 2 is,
that's catchy.
PLC Heartbeat. Control Alt Delete the Downtime. Ethernet to the Assembly Line. Sensor Symphony. The Cloud Meets the Crane. Legacy Code on the Conveyor Belt. I think I'm going to ask for lyrics for that one.
Oh, man.
Yep. Yeah, this is okay.
This is a greatest hits album.
It is. Patching the Pipeline Blues. Data Lake overflowing with diamonds and defects. Cyberstorm on the shop floor. Oh, okay. What are the lyrics for Legacy Code on the Conveyor Belt? Here we go. Okay, here are some potential lyrics. Sunrise paints the factory gray, another shift begins. The gears are turning, come what may, fueled by forgotten sins. Down in the server room it hums, a relic old and vast. That ancient codebase softly strums a ghost from our past.
This is giving Metallica a run for their money.
Yeah. They say it ran the mill for years before the internet's call. Now every tweak just fuels our fears of watching the whole thing fall.
This is rhymes. That's awesome.
It does. The chorus is Legacy Code on the Conveyor Belt, a digital dinosaur, held together with hope and stealth and prayers behind the door. Each line a mystery untold, each function a dark art. This system's getting mighty old, tearing our nerves apart.
My God. Wow. It's like they know what's happening in our heads.
It's like so accurate, right?
Okay, we're gonna get those lyrics, and we're gonna have that other service make our song. So, Ken, I'll even share this with you. So, if you, like I said, I paid for this service, so I have commercial rights for it.
This is our end credits tune. Whatever it is, this is our end credits tune.
I'm clicking create right now. Now I have to ask the other. Well, what style is the music in 200 characters?
Lance, I'm going to be a little bit more classical here, but, I hear some of those lyrics and I almost go back to like Megadeth, Symphony of Destruction,
Yeah, like this is definitely a
metal.
Big Four, like, kind of rock album.
Okay, so we're going to say
maybe
musical style.
Mid-90s hard rock backed by symphony?
Mid-90s hard rock
backed with symphony.
Backed by a symphony. Okay, there we go.
Oh my God.
And this is going to be great. Legacy Code on the Conveyor Belt. And we're going to go ahead and click that create button. Here we go. It's going to be coming up on my computer shortly, and I'll share it with everybody in a moment.
This is the highlight of my day right here.
Oh, see, this is the reason why I actually paid for this, because here's your 10 free, and I just couldn't stop. Okay.
Just a taste, right?
Oh, yeah.
It's just like drug you into its world now.
One of the things I like about this one is it creates two. So, Ken, you're going to have to select which one you want to play.
Welcome back to OT After Hours, podcast about industrial cybersecurity, why it matters, and all of the challenges that it presents. And if that preamble didn't encapsulate literally the entire topic of, or the entire theme of the podcast, I don't know what does. But just doing a quick roundtable here, going around, the icon staring back at me from the screen. We have with us again this time around Tyler Bergman. How you doing, Tyler?
Hey, Ken. Always good as always.
Sweet deal. Zach Woltjer is also back.
Hey, good to be back.
Yeah. And joining us again as well is Natalie Kalinowski.
Happy to be here.
And spinning the tunes, and do tune in at the end of the show. I'll pick one of those two tracks and we'll see what has been cooked up. But spinning the tracks, DJ Lance Lamont.
Thanks, Ken.
Good to have you back, all. So, in a roundabout way, actually, everything that we were just joking about there relates to the topic at hand. Oh, right. My own introduction. I continue to be Kenneth Kully. Thank you for tuning in again. Anyways, like I was saying, in a roundabout way, all of what we were just discussing there relates to the topic at hand, which I believe was your suggestion, Tyler, where we actually wanted to get into the nitty-gritty of like asset management and some of the different strategies for inventorying assets within an environment. And again, I mean, Verve makes an asset inventorying software. So we have a particular approach to this. Is ours the only approach that is out there? Absolutely not. And so the idea, at least with this episode, is to kind of tease out some of those different strategies for inventorying your assets and understanding what is out there on your network. Because, and again, you know, like that, the song and the lyrics there that the AI has happily generated for us really do get to a core issue that a lot of companies out there that we encounter, a lot of companies that I know I encountered, you know, in previous stages of my career have, which is that you don't, I mean, the first problem is you have to know what you have. And especially as you have things like mergers and acquisitions, especially as you have staff turnover over the long lifetimes of plants and plant equipment, it really is challenging to maintain that detailed understanding of what's out there in your network environment, within your plant, on your shop floor, or out in the field, if you're doing some sort of distributed system. And beyond that, of course, there is the issue of legacy equipment versus new equipment, right? You know, do you have really old equipment, but it's hooked up to some important part of your process and you can't just change it out on the fly? What do you do with it if it is out there? Do you even know that it's out there? How do you find it if it's out there? And then once you actually start down that road, what are the different strategies you can take to actually discover and manage all of those assets that are out there that you need to be aware of? And in the preparatory phase for this, we kind of zeroed in on 3 different strategies. And I think we'll probably tackle them in order because there's value to each. And I think, you know, the best way I can put it is that there's value to each of these, but the richness of the information you get back kind of increases as you move along from one category to the next. So broadly speaking, the 3 strategies that we identified were manual data collection, passive inventorying, and then active inventorying. And I mean, I think maybe Lance, I'll let you kick this one off because you really kind of zeroed in on some of the value of manual inventory and manual asset data collection. Because, I mean, it's very easy to, you know, sort of like, and you pointed this out in sort of the preamble chat, is that, you know, do we want to like really, we shouldn't downplay manual. I mean, it is by far the most time-consuming way to go about collecting information. If you're trying to do it within a plant environment, it's a lot of boots on the ground time. It's a lot of digging around in cabinets and whatever else. But it does have a certain value from an engineering standpoint.
Oh, absolutely. So, you know, we were trying to talk about the different aspects in the, like you mentioned, of the pre-conversation. And one of the things I wanted to really point out is manual has a significant advantage in that you're not doing anything to impact the data on the network. You're not doing anything to even alter a switch configuration or anything else. You've got this very, very hands-off way from an electronically hands-off but a very hands-on physically way to get some basic information from devices. And it can be a very good way to have essentially no impact on what's happening on the network when you do it in a manual format. Obviously, you might not be able to get as much information, but it's a really good way to start to understand what's going on.
And there's a little bit more to it than just,
of course,
walking around, with a checklist and being just like, yep, there's a computer over there. We'll, write down, found a computer. When we're talking about manual data gathering from an asset, I mean, obviously, yeah, you are doing that verification step. You're actually physically verifying that the asset is there. And, hopefully you're going in and you're collecting some basic information as much as you can. Like, if it's a computer, does it have a host name? What's its IP address? We've done this in some other cases where we found like one-off assets in client environments that we don't have driver support for. But, okay, fine. Like this thing might be running, like it might expose a really simple web server. So I can get onto something that can see it, and I can bring up a browser and I can navigate to its address and I can look at it, and I can, sometimes these pages are a little more than a login screen, and there's not really anything that a login screen should tell you. Sometimes, though, you go to that little web server that the device is running, and it will happily tell you, like, oh, yeah, I'm a this is my make and model number. This is the firmware version I'm running. Here's the voltages I'm currently monitoring, and all of these sorts of things. It really depends. So taking those steps to, manually investigate an asset a little bit. And again, in that really sort of unintrusive way. Obviously, you don't want to log in, change settings, anything like that. But if you can just, take a look and see what the asset is able to tell you without putting any additional workload on it in terms of, processing, network bandwidth, anything like that, that gives you more information than not knowing that it's there, or just simply, taking note of the fact that, okay, yeah, there's a computer in the corner of this particular control room. But, and actually, it's really, really good, too, that you mentioned the network bandwidth angle, because Natalie, you, when you were kind of putting together some prep notes, you really kind of zeroed in on a couple of different articles that talked about that, and talked about how one of the major advantages of passive discovery is the fact that you're not putting additional traffic onto a network.
Yeah, so I think from some of the research I did, whenever you're using a passive method of communication with devices, essentially they say it removes the issues of network bandwidth consumption, which it can mean, like passive can mean a few things. So it depends on how it's looking at devices. So are they just gathering information on ARP tables, or are we gathering more information from devices like data? So I think when we're talking about passive discovery from devices and the impact it has on network bandwidth, it really depends on the passive tool and what it's actually gathering from devices.
Yeah. And I mean, that makes sense because, I remember, again, got to go back like 12 years for this, but I remember setting up SecureOT at the place I was working at the time. And one of the ways that SecureOT works, or can work, is if you take a switch port, like on a Cisco device, and flip it into promiscuous mode, and then you can hook SecureOT up to that, and it'll basically just get a copy of all of the network traffic, or at least as much of the network traffic as the switch can reasonably copy over to the port. Depending on the speed of the port and the speed and utilization of the rest of the network, you might still have data getting dropped. But the idea behind configuring a switch port like that is that it basically just gets a copy of all the network traffic, and then you can plug in something like SecureOT to listen to all of that. A passive scanning tool can ingest all of that just raw network traffic and glean a lot of information about what is actually happening on the network and what devices are connected to it. So that is one form of passive network scanning. The other one, like you mentioned, is, if you have the ability to log into a device, whether that's like a Cisco switch via SSH, or if you have like a little agent deployed to a Windows endpoint, anything that's connected to the network, most things that are connected to the network, not all, I shouldn't say all, but a lot of things that are connected to a network will maintain their own little internal tables of what they're seeing, whether that's the ARP table, the routing table. They will see the broadcast traffic going back and forth, as well as, the traffic that they are sending and receiving themselves. And this will often get stored in parts of the OS, parts of the working memory of the device that then we can access, and we can, and not just us, many scanning tools can access and translate into essentially a map of assets that are out there, or at least a list of the other assets that are out there on the network. So yeah, you're right. Passive can mean a few different things, but the main advantage of passive is that you're working within the network traffic that's already present. You're not putting any additional traffic into the network. You're just sort of taking the traffic that's flowing through the network already and pulling information out of that to the best of your abilities. Now, to be fair, not every device will broadcast everything about itself onto the network in a way that will allow you to then sniff it if you're just doing passive monitoring. You will still get a lot of useful information, though, but you won't necessarily get the finer, more granular details that you would by actually reaching out to an asset.
Well, and I think, Ken, there's a couple of components there too. So when you're doing passive, you're just trying to look at the activity going across a wire and see if it provides any type of identifying information for you. So, there's a couple of different components when I think of passive out there. So I think about some of the different tooling out there, like SecureOT, for example, that you gave out there, as far as trying to do any type of distinct detection for anomalous network behavior, right? So there's kind of that mindset that's out there within the ecosystem, right? Of just trying to do detection within the network, but on top of all the data traffic that we're ingesting and we're sensing all this data, we're going to build kind of an aggregate table of asset information out there based on what these endpoints are that are causing these traffic. Now, there's also little caveats to that as well, is, where you set your taps into the network or span ports, as far as the data that you're going to be able to see and ingest, right? So if you've got the larger plant network as a whole, but you're not capturing like device level rings per se that are more pertinent for like a controller area network that is for its own intrinsic IO and communication structure, you're probably not going to get a lot of that type of componentry in there, right? Or if like one of the more active ways that we get out there to them is we'll actually traverse the backplane and talk to that remote IO that's on that different Ethernet segment behind that controller to be able to pull that stuff back and get all the identifying information. So, and one of the other things that I've seen out there too is like some of the passive tooling out there will tell you, it's like, okay, well, once you get all the taps configured up and going, go into your engineering tools and then pull up the information for each and every single one of your components so we can actually ingest that data. So instead of inferring it, you're actually capturing it off of good data that you're trying to pass across the network over to diagnostic utility to be able to capture that information too, right? Mm-hmm. But, that from a practical standpoint, are you going to do that every time something changes out there and things of that nature too? So I think there's an opportunistic out there for both in most ways to make sure that you got all your bases covered out there for sure. Because I think, as you mature through your security mindset, you may get to a point where, okay, I've got a very wealth of understanding of what my assets are out there, but I want a little bit better perception on, maybe detection out there for anomalous traffic. So that way it gives me a little bit more indicators out there of what potentials could happen, or I'm maybe feeding that into an AI system for anomalous behavior based approach type of sensing type of things too. So it kind of comes down to where you are in your journey, the practicalities, cost. I know that's kind of the all ruling factors and everything like that as it comes about too, right?
Yep.
So trying to apply some best methods out there based on where you're at in your security journey too, right?
Yeah, absolutely. And to be fair, I can appreciate the need to be careful with utilizing network bandwidth in a process environment. I mean, this is becoming less of an issue, but like I can remember previous life working for a different company, and we were dealing with this one particular control system that everything was capped at 100 megabit. Okay, fine. But, it was already a pretty busy network, large domain, lots of operator workstations, servers, historians, process servers, monitoring, all of that stuff, all talking on the network. And because it wasn't built with virtual machines, it was built with mainly physical workstations, backups were also being captured over the same network. And it was rather like clockwork, actually, or it got to the point where it was rather like clockwork, where every time a backup of one of the historian or process servers kicked off, you could reliably count on the control system to start complaining about data integrity because communications were getting stomped on. Right. The backup traffic was significant. It was large. And it's a backup. It's a multi-gigabyte backup. Of course, it's a chunk of network bandwidth. And even when we tried to apply some caps and limits, it didn't always solve the problem, because now all of a sudden the backup's like, okay, well, I'll need 5 days to finish. That doesn't really help us either. But, we don't want to stomp on controls traffic. We don't want to create gaps in important process data. And so what do? It became less of a problem when they were able to virtualize parts of the system, because if you're doing it virtually, then, you can have a backup agent VM running right on the virtual host, and it can just use the snapshotting infrastructure to capture the machines. It doesn't touch the network at all. So that was better. And I mean, nowadays it's less of an issue again, because not too many control systems, unless you're dealing with really, really legacy stuff. Oh, right. That was the closing song. Are going to cap you at some lower bandwidth. Most things can do gigabit, or in some cases even faster. So I can definitely appreciate the caution that we have to approach putting additional traffic on to the network with, whether that's because we want to actually log into a device, or execute some sort of query commands against a device to pull information back, or whether that's because we actually do want to do a fine-tuned network sweep to actually to actually go out and try and discover new devices that might be out there that don't communicate all that often, and so don't necessarily show up in ARP tables, because those have a time life. Those have a limited shelf life. ARP table entries do. But, and one of the things I think that's really great about the Verve platform that I've really, thought is one of its major strengths, high marketing, is that we are sensitive to the fact that a lot of our customer environments may be in this situation where you can't just have a large amount of additional traffic come onto the network. And so all of our stuff is really, really fine-tuned to introduce a very negligible amount of additional communications onto the network by design. And then further is schedulable beyond that. So, we can cap the number of times it'll retry communications. We can fine-tune when a particular query job is going to run. And even then, when those jobs run, at most removing, a few additional kilobytes back and forth. Certainly not, anything like a multi-gigabyte server backup.
Ken, I wanted to bring up two things based on what you just said. Excuse me.
Go on.
The first thing is we should differentiate discovery from gathering information, right? There's the process of identifying new devices on the network, and we look at that as discovery, and we can look at all of the discovery as a manual process. We can look at it as a passive or an active process. And then we can also look at just the data asset information gathering as an entirely separate aspect there, where once again, we can do that manually. You read the label on the side of the device, passively trying to gather the information from the packets, or actively gathering the information from the device directly. When we look at the Verve platform, I hang out in the engineering back side of the Verve software most of the time, one of the things we really try to emphasize and pride ourselves on is the absolute minimum number of packets and size of packets to gather the critical information that we need. So, hey, can we do this in 3 packets that are going to impact this device as minimally as possible? Are we confident that those packets are formed exactly correctly for the device that we're interacting with? And are we confident that even if there were an error on the line while we're interacting with this device, that the device is not going to be negatively impacted? So we do all sorts of things to try to keep that data bandwidth as low as possible when it comes to gathering the information from devices.
Absolutely.
Yeah, Lance, you bring up an interesting point out there. So one of the kind of fundamental things that I'm always always cognizant about it when we're like hitting network access. So I think dive in a little bit more deeper into the nuts and bolts of how we do our asset discovery, right? So one of the initial ones that, we like to do is that passive one, right? Because it's very, very low impact, not obtrusive to go out there to grab things. So kind of an initial, just kind of getting a feel for the environment. My first lever that I usually grab is like the whatever the boundary firewall is, or whatever that layer 3 boundary is, because it should, and I'm doing air quotes over here, should know, at least effectively what's trying to communicate on the network or trying to get out on a recurring basis, right?
Sure.
So by connecting to that device and then just scraping all the ARP tables out of it, we've got a fairly decent idea of all the different layer 3 devices that are out there that are trying to communicate on the network, of all the attached networks that are on that particular firewall. And, you could have 1 to 3 to 4 to 5 to however many you're doing for layer 3 network segments out there. And hopefully you're not doing anything, super crazy by having, multiple layer 3 subnets on a one VLAN out there, which I know probably the majority on this call have seen out there as well on flat networks as well. So, by and large, we're able to get a lot off of that, but still trying to get into some of the nitty-gritty details out there too. We've found that you also need to have some of that more active component too. And that's kind of where our agent approach comes into play when we're talking to some of the OS assets out there, because on the back end, we can have that sweep through onto IP address ranges that are attached to the OS asset and do like a simple ping sweep out there to see what's responding out there and go from there. And then even up to the point of having like a simplistic port knock on some very widely known ports that are available. So it's nothing very obtrusive like you would have with like a Nmap scan against an endpoint with all ports that we know instantaneously. We know that it's going to blow up a pretty good portion of these OT assets out there, because they're pretty sensitive. You can't go knocking on them with Nmap unabated or anything like that, right? So it's kind of having that knowledgeable approach when you're looking for these assets, knowing that some are sensitive to different means out there, and making sure that you're not causing any type of weirdness in the environment as you're going out there. And I know there's several books out there that have decided, and I know we've talked about this in the past, as far as, even sending a single ping to a device, send it into like a reset state. And, it wasn't really good. And I'm just sitting here thinking to myself, I was like, who would build a device that a simple one ping to it would throw it into like a reset type of situation? That just seems off to me for whatever reason,
So this is an interesting topic, and I can talk on this topic a lot. Strange devices we've interacted with and how they can go wrong. It's one of the things I mentioned earlier, the how do we safely interact with devices. We, at the research team side of things, we interact with many, many devices, and we have absolutely found devices where, hey, if you send a 5 to it instead of a 4 in the packet, which is still a properly formatted packet, it will crash the device or it'll knock it off of a network. We've found all of those sorts of devices. And it's definitely concerning, but when we look at these devices, part of what we do, part of the behind the scenes, how we make our drivers is to recognize those risks. And in the case of that device, which obviously I won't name names, in the case of that device, we took an entirely different approach. We went to a different protocol, so there was no reasonable way where we could accidentally knock that device off the network. We did report that specific issue to that product vendor, and that product vendor came back with this is operating as designed, which was a very interesting response. But when I look at that sort of scenario, from the other side, when I've been writing embedded firmware, that's a previous career of mine, it makes some sense when you realize that many of these devices, at least initially, weren't intended to be on a network, and they just sort of patched this functionality in later. And quite often when you do some basic testing, you're testing the good path and you forget to test the bad path. Obviously, most manufacturers of these products are much, much, much better than that now. But when we look at old devices, we can still run into that.
Oh yeah, for sure. And it's kind of like one of those things you're obligated to tell them about it, but they'll always come back and say, it is working as advertised, and well, that functionality is there. And speaking from a malicious actor standpoint, I mean that's 100% a denial of service
absolutely
capability type of thing, So yeah, you just run into all types of little caveats out there for things, and we just kind of inherently know that about these devices because, like you said, they weren't inherently known to be like widespread out, talking to multiple different devices and malformed packets and all this other type of things going on. So it was just like, we're just going to implement this over there. We're not going to run it through all the different baddies that it could potentially do with the fuzzing and all those things. Right. Because it's going to be a very isolated device. And then by and large, the most part, they are. That's why you should never put in your OT devices on the general internet, right?
Absolutely.
So shout out the Shodan out there, one of those things. So I guess, kind of what's next into it. We talked about active, we talked about passive. And, what's some of the practical considerations that goes into it?
I mean, I would probably say a question I get when I talk to people in the operational floor is how quickly will they get information? So when you look at an active method or a passive method, one of them is going to give you continuous monitoring. And then that's good because then you're going to get active information. But then, like we were saying, there's some, drawbacks to that as well when we look at like the network or other aspects. But then with active, like Ken was saying, is that it's all scheduled out, that you can kind of figure out which devices you want to communicate with, when and how often, especially depending on where they are in the facility. So I feel like that would be the next conversation topic, is the timing of these and how important it is to have recent information, or is it okay to have information that's a little out of date for an OT environment?
That's an interesting topic, Natalie, and that might be something that we could bring up later on one of our podcasts too, is just say, we're trying to get you that data, but how do we paint that picture for you of where you're at and some potential inroads that you can do for other initiatives to help mitigate some of your security risks and do some other certain things out there, whether it be network segmentation or micro segmentation if you're already doing like a stereotypical segmentation out there. A couple of different components that we can talk with you about out there, depending on what your situation is and where you're at in your cybersecurity journey, right?
Yeah.
Oh, good deal. Yeah. So I think really the future is bright out there. It's I think so tell you what, Zach, what do you think are some of the major highlights out there? As we're going through some of the larger aspect out there, you're going through there, you're trying to pick passive or active, and then you're trying to dream up where you want to go in your whole journey out there. Maybe start from like a very initial baseline and then kind of talk us out a little bit.
Yeah, absolutely. I think, I think that's dead on. Kind of where you're at in your journey is kind of where each of these collection methods are going to come into play, right? So if you have already used other services, if you've already collected some data, you'll be able to use that manual information to pull over into a centralized repository like Verve. And then, kind of as you get a little bit more mature or, right off the bat, getting into it a little bit more invested, working passively. I mean, I'm a huge proponent of passive collection, of collecting all of that data passively, just because, this is, I don't want to say it's like the lazy answer, but, if the data is already, flying across the wire, why not grab it? You know what I mean? Why not be able to collect that information just for the means of getting a good asset inventory, a good software inventory, users that are active out there. Oh, there's so much data that can be collected passively that's just coming across the wire. It makes sense to just start grabbing that data as it's going across. And then, kind of just summing this up with active, like each of these elements is to further that eventual active data, right? Because the idea is almost every asset you're going to have on your network is going to be using or is going to be either actively going across the network or it needs to be how do I phrase this? It needs to be interrogated. Maybe that's not the right word, especially within the OT industry, but it needs to be actively collected. It needs some sort of more active means of data collection, I guess, is probably the best way to phrase that. But I think that really is what sets Verve apart. I've gone to several conferences and stuff, and I've listened to other industry partners or other OT specialists. And one of the big questions, just kind of reinforcing what Natalie was saying about speed. But another thing that a lot of people will ask is, how noisy is this on my infrastructure? We're doing our business operations and we want to be able to get a good asset inventory, but we don't want to do it at the cost of messing with current production lines. And I've heard so many other OT ICS specialists simply say, I don't know, it depends on your infrastructure. And I think that's really what makes Verve so different, is that we do know, we can come in, we can quietly come at it from a passive collection means, and then further expand that out to more active means as needed. Until we are confident in an asset inventory and a software inventory that can be pulled from all of that. That, to me, that's the big thing. To me, when it comes to asset inventory, that's, especially in the OT industry, I think that's so huge. Like, speed, yes, that's very, very critical. But I think with how fragile so many of the OT devices are, I think the noise that is created by a cybersecurity platform like Verve, I think that's just paramount, because, kind of as Lance was saying before, and really just kind of trying to hit this nail home, if you're trying to gain your asset inventory and you go out there and suddenly, half your production line is down because you're pinging like a wildebeest just out there, just slashing around trying to get all of the assets, it's not going to be very helpful for anybody, right? So being able to get that specialized, this sounds goofy, but being able to get that specialized care and love to each of the devices, depending upon the best way to collect them, I think that is just absolutely paramount. So that's really my insight on this. I think each of the three, like, there's kind of a time and a place for each of them. Me personally, though, I will drive passive until I basically have to use active.
Yeah, a little bit further behind the scenes, we do almost have contests among the engineers. I'm not going to say too loud who, but to see how much information we can get with how few packets. So yeah, we absolutely, you mentioned the love and care when we create our drivers and interact with the devices. We don't speak too loudly about it, but absolutely, we have a lot of, I'm just going to use the word fun. We have a lot of fun trying to figure out how well we can gather information with the absolute minimum impact to our networks. And one other aspect you didn't mention, but that our drivers have to be able to handle is some of these incredibly high latency networks that we operate on. Multiple second pings between devices, that sort of stuff. And we've been able to successfully gather lots of good information in a minimally impactful way on even those huge like cellular and various other wireless connections.
I hope Rockwell eventually makes like a capture the flag for this. Just have somebody out there just trying to ping and get a good asset inventory and then have a blue team try to spot them. I think that'd be cool.
Oh, yeah, absolutely. Actually, I think the way we'd be recognized is, wait, there's so few packets coming from that network address to that device. Maybe it's us.
If you can't brag about that, I don't think there's anything like that's awesome.
That is the strength of the platform right there, is the fact that it's just, it does allow for, very tailored, fine-tuned data collection in like just that most minimally obtrusive way, because hey, at the end of the day, we want to keep those production lines running, but we do want to know what's out there helping them run in the first place.
Absolutely.
This week, in lieu of a question, we thought that we would try something a little bit different. We're going to ask you a question. Now, to be fair, if you still want to ask us questions, you can do so at the OT After Hours webpage on Libsyn. Check the show notes for the link. But this week, we have a question for you. As you've heard us joking about throughout the course of the episode, Lance has cooked up a couple of OT cybersecurity themed music tracks using Suno AI. This is the first one.
Legacy code on the conveyor belt, a digital dinosaur, held together with hope and stealth and prayers behind the door. Each line a mystery untold, each function a dark art. This system's getting mighty old, tearing our nerves apart.
And this is the second one.
Legacy code on the conveyor belt, a digital dinosaur, held together with hope and stealth and prayers behind the door. Each line a mystery untold, each function a dark art. This system's getting mighty old, tearing our nerves apart.
Now, I'm going to include links to the full versions of both songs in the show notes. And then, if you look on LinkedIn, I'll have to update the show notes after the fact once this post goes live. But if you look on LinkedIn, on like the Verve Industrial page, there'll be a post about this episode, and it'll have a poll attached to it. And you're invited to let us know which of the two songs, which of the two versions of the song is your favorite. And whichever one wins, we'll release as a download next episode. And we might also continue to use it for show music. Not sure. But at the very least, we will make available as a download whichever one proves to be the more popular version. So look for us on LinkedIn. Look for a post about this episode on LinkedIn. Look for the poll. Cast your vote. And then next month, we'll release one or the other. Okay. Well, a little bit of a shorter episode, but I think just nice, focused, and with what I hope is going to be some absolutely banger closeout music from DJ Lance and his AI adventures. But all right. Thank you, everybody, for coming together and for pulling this one together on relatively short notice. And thank you for all your research ahead of time. That was amazing. I just loved seeing the discussion kind of emerge today as everything kind of coalesced around this topic. So really, really awesome. So that's it for this month. You have been listening to OT After Hours, a podcast about industrial cybersecurity, why it matters, and all of the challenges that it presents. Please share our episodes with your friends, family, colleagues, and anyone else you think would be interested in industrial cybersecurity. And please consider leaving us a 5-star review on Apple Podcasts, Podchaser, or wherever you get your podcasts. This podcast has been produced by me, Kenneth Kully. Our opening and closing music is by the ever-so-talented Octo Sound. Look them up if you need music for a podcast or a video. Thank you, Lance. Thank you, Tyler. Thank you, Zach. Thank you, Natalie. And thank you out there for listening. We'll talk to you soon.
Legacy code on the conveyor belt, a digital dinosaur, held together with hope and stealth and prayers behind the door. Each line a mystery untold, each function a dark art. This system's getting mighty old, tearing our nerves apart.